Welcome to Module 3, Lesson 10, Angle Problems and Solving Equations. So in this lesson 10 and in the following lesson 11, you are going to apply your understanding of equations to unknown angle problems, okay? So this whole geometry topic is a natural context, and we've talked a lot about context throughout this year, about putting numbers into context, a real situation. But they're a natural within which we can apply our new algebraic skills, okay? This unknown angle, okay, is an actual measurable angle. What you guys and girls are going to need to do is just to find the value that makes each equation true. Okay, and you're going to set up all your equations based on the angle facts that you've learned in the past. Okay, as far back as grade 4, we learned some facts about how angles are related to one another, and we'll talk a little bit about that as we move along. Okay, so with no further ado, let's look at three angles. Okay, so take a look at these three figures, figure 1, figure 2, and figure 3, okay, and just want you to think about, just what do you notice about the three figures? What is the same about all of these, and what is different, okay, what is different? Again, there are some notes on here that you can probably use to help you out, but we could just cut to the chase here and say they're all the same. Okay, they're all equivalent, or they're all congruent. Okay, they're all the same measure of angle. Okay, but what we do notice is that they are notated differently. Okay, they're notated differently. In Figure 1, and again, excuse me, the measurement we're looking for always is going to be the same. Okay, we're looking for the angle or the degree measurement of the angle right over here. Okay, but in this case, in Figure 1, it's being named by the arc itself. Okay, and that arc notation is this little curved line right here. Hopefully you guys have used that before, have seen that before, and of course you can see B and then B degrees. Okay, that little degree sign right there. Okay, so that's the unknown angle in this picture right here, in this image. Okay, it's named by the arc itself. Okay, so you might B degrees. So B, that's what you're solving for. What this B degrees is going to be. Now with Figure 2, it's notated by the vertex. Okay, by the vertex, and you can see that right here. This little line there, or this little symbol, the symbol before the A. Actually, I didn't talk about that over here as well, but over here as well. Okay, it means angle. Okay, that stands for angle. This little symbol. Okay, all right. So angle A, and that's being named by the vertex, and the vertex is that point right there. Okay, that corner place where 2 points meet, okay, or where 2 lines meet. Okay, that vertex right there, being named by the vertex. And again, these are just different ways you're going to be able to see it. You'll be seeing it presented in the problems that we'll be solving. Now, in Figure 3, it names it by the 3 points that make up the angle. Okay, and you can see that right here. You could call this angle CAD, or you could call it angle DAC. Okay, CAD would be this way, CAD, or DAC. Okay, and they all, of course, talk about the same thing, the angle of that corner right there. Okay, or that angle right there. Okay, so they're all asking for the same thing. They're just notating it a little bit differently. Okay. All right. So what we're going to do now is we're going to go ahead and we're going to look at this, your first page in your binder. Okay, and let's go ahead and talk about angles and different names of angle relationships, which are going to help us before we get into get into solving some equations. Okay, so hopefully you're coming to this discussion with some knowledge of angles, okay, and the different types of angle relationships. If not, and this is really the first time you're hearing this, please do listen closely and please do take good notes, okay? So our first angle relationship, what we're going to talk about here, are adjacent, okay? That word is adjacent, and if you can say that over and over until you know how to pronounce it properly, that'd be super. But yeah, adjacent angles. Okay, now adjacent angles are angles that are actually side by side. Okay, they're side by side. Now there are other ways. We'll write it down. When I write in the angle fact here, I'm going to go ahead and use some geometrical language or geometric notation to have you write these facts and definitions as well. Okay, but you can see that A here and B are what we call adjacent angles, and you can see they are next to each other. Okay, they are right next to each other. One is here, and then one is right there. Okay, so they are right next to each other. Okay, now so let's say for example, so two angles. Well, let me go ahead. I'm going to go ahead and write down some definitions and facts in this box right here for adjacent angles first, and then you can come back and I'd like for you to write those as well, so we can remember these. Okay, understanding adjacent angles is probably simpler than the definition, that's for sure. So, but let's try to make this as clear as at least not so muddy water. Okay, so two angles are adjacent when they share a common side. Okay, so we can see right here. Let's talk about two angles in particular. Let's talk about BAC. Okay, and this one here, we're talking about angle BAC. As you can see, is right here, BAC. Okay, and then we can talk about angle CAD. CAD. Let's do that in a different color. Okay, so now we have CAD. Okay, all right, so angle CAD. Okay, so we're talking about these two as being adjacent, okay? They share a common side, as you can see, which is this here. This is their common side, all right? This line right here. Okay, that's their common side, okay? So common side. I don't know if you want to just write some notes. Now, on this common side, though, a point must exist on that common side that belongs to the interior of the angle they form together. Okay, so they do form an angle together. In fact, they form a larger angle, which is, as you see right here, is BAD. Okay, that's that larger angle, right? So these two together, equal angle BAD. Angle bad. But they share a common side, and on that common side there are points. And here's like that, for example, there's that point C right there. Okay? I know it might not be, again, like I said, the definition is probably more confusing than the actual idea of an adjacent angles. But maybe we'll see in this lesson some non-examples that we can compare them to. Okay? All right, so and again, we'll get to some definitions also at the end of this lesson. Here is another type of angle relationship, and these are vertical angles. Okay, vertical angles, which could also be abbreviated like this. Okay, vertical angles. All right, and you can see these vertical angles just by looking at them. You might be able to get a definition of what they. Of what their definition is. And firstly, you may see also, if you look at angle A and that angle B there, what do you notice about those two? Very important, very important aspect of a vertical angle, which did not apply to an adjacent angle. But very, very important part of this is they are equal. Okay. Okay, so vertical angles are equal. So in this case, A equals B, as you can see right here. Okay, A equals B. They are the same measure. They are the same degrees. Okay, let me go ahead and I'll finish up writing some notes down here, and you can come back and we could talk again. I don't want to waste too much time talking and writing. Okay, so another aspect of vertical angles, not only are they equal, as you can see, A equals B here, okay, as we had mentioned, angle A equals angle B, but their sides form two pairs of opposite rays, okay, so you have, this ray here, CG is moving this way, and then, CE is moving this way, and then CF, CD moving that way. Okay, so these rays are moving opposite ways. Okay, their sides, as you can see, they're moving to the opposite direction. Okay, which may not always be the case. Okay, but they have to be if they're going to be considered vertical angles. Okay, next definition or facts we need to consider is this idea of angles on a line. Okay, angles on a line. All right, very, 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 very important fact to understand when you're solving equations. Is that very simply angles on a line are going to add up to 180 degrees, okay? So in this case we have angle A, angle B, angle C, okay? So in this case all this is going to be A plus B, A plus B, A plus B plus C is going to equal 180 degrees, okay? So those angles, whenever you have a line, okay, like this line here, BE, okay, going across here, and then you have angles that are formed by other rays coming off of that line, okay, whatever angles that are formed, in this case we've created by by drawing those two rays that way, we have created three different angles. Okay, we've created angle A, angle B, and then angle C here. Okay, and they can be named differently, but these are all going to equal 180. They're going to, and again, I know some of you know this already, but just an important fact to keep in mind or to remember, I guess we could say. Yeah, all of those. So the sum of the measures of any angles that share a ray and form a line is 180 degrees. Okay, 180 degrees. Now angles at a point, this is this next one here. Okay, angles at a point, and you can see here we have one point, this point here. Okay, point A. All right. So if we have, so the measure of all angles formed by three or more rays with the same vertex is 360 degrees. So let me go ahead and write that down, and I'm going to pause here for a second. Okay, so the measure of all angles formed by, and again, this is important, three or more rays. And again, maybe some of you don't or have forgotten what ray meant, but a ray is is a line that actually has one end point and one that continues on. Okay, and it starts at one point, particular point. In this case is A. Okay, because that's the vertex from which all of these rays emerge from. Okay, and all these are rays because they have one end point, and then they continue on in that direction. Okay. All right, so those are rays. And again, it has to be three or more rays, okay, that come out or share a vertex. Okay, so the sum or the measure of all of those is going to equal 360. So in this case, this would be, A plus B plus C would equal 360 here. Okay. Okay, where A plus B plus C equaled 180 up here, but we were talking about a line here. Okay, we weren't talking about a line. So there's no line, no line in drawn in this this example right here. Angles at a point. Okay, and another way to say this one here would be, for example, we have angle BAC plus angle BAD plus angle CAD. Okay, that equals 360. Right, it's another way to notate it, and you can see because I'm talking about now I've talking about them in terms of angles. I went BAC is right here. Okay, BAC, and then BAD went this way, and then CAD went that way. I don't know if you could see that, but yeah, just another way. We can use this notation because we're talking about these that measuring the arc, and then we can do it in this notation because we're talking about using points on the lines that form the angles, and we could have done the same over here as well. Okay, just so you know. Okay, so go ahead and with that knowledge, and again, of course, you can go back to that page to use your notes. Go ahead and name all of the angles. I'll name the angles in this diagram right here, to your right here, this diagram. All that are vertical, adjacent, angles on a line, angles at a point. Okay, so if you would go now, there may be several answers for different questions, but at least give me a few of each if you can. Okay, so here we go. These are some answers that, and you may have other answers too, but I think you'll be able to understand that your answers were correct or incorrect just based on the answers that I give. So here we go. We have, for example, vertical. Talk about vertical first. We have AEC. AEC, okay, and then we have BED, okay, and you can see, boy, I did a terribly messy job there. So AEC, BED, okay, so these two angles here are vertical, and if you look at it, you'll see that there's 53 degrees there, 53 degrees there, because what we know about vertical angles is that they are congruent or equivalent or they're equal. Okay, and then there was, let's get rid of all that. And another one we can see is, let's see, CEB and DEA, okay, and that one maybe not as noticeable, okay, but you can see if you did go ahead and add up the angles here. You had 90 plus 37, that's 127. And then if you had 79 plus 48, that was also 127 degrees, okay? So those two are also vertical, okay? All right, and a straight vertical, except for the first two I talked about, you wouldn't be able to see because there are the only two that are clearly vertical that we can see just by here are these two as AEC and BED, but the others would have taken some creativity. So hopefully you're able to find those. Okay, and adjacent. All right, adjacent. Now we're right here. Change to my green. And now some adjacent angles. We had AE, plenty of these, AEC and CEF. Okay, right there and there. You can see these are adjacent. Has nothing to do with their measurement, of course, but it does have to do with the fact that they have this common side, and a point on that common side is going to be in the interior of the larger angle, which is, in this case, AEF. Okay, so adjacent side by side, as you can see them. Okay, another one would be CEF, and then FEB. Boom, boom, right there. Okay, adjacent again, side by side, sharing a common side. And again, there'd be a number of those. Okay, I'm not sure what you put, but you have a pretty good idea of what is an adjacent angle. Again, nothing to do with measurement, only to do with location and the sharing of a side. Okay, angles on a line, and again, with angles on a line, what we're looking for here is we're looking for 180 degrees total. Okay, you're looking for a total of 180 degrees. And if we look, you could just looked at the numbers, the degree measurements here. Okay, and if you could actually find you can add those up if you wanted to. All right, but you can also just look for a line. Okay, and here's a line right here. Okay, I've got a line. So off of that line, we could have used AEC. Okay, AEC here, and that's 53 degrees. And CEF, which was 79 degrees, and then FEB, which is 48 degrees. Okay, now we can pretty much tell. Okay, it's not always safe bet to tell a line is a line, but if we did go ahead and add these up, 53 plus 79 plus 48, we would have come up with 180 degrees. Okay, 180 degrees right there. So they are angles on a line, and of course those on the bottom underneath here, all of these, if you did that, they are also angles on a line. Okay. All right. So the next one is, or the last one is angles at a point. Okay, and again, angles at a point, very special relationship. Three or more rays coming off of a familiar point, and in this case, this familiar point is going to be A, and it'll be E. Okay, because all of these rays are coming off of E, as you see right there. Okay, all these rays coming off of E. All right. So an example of this could have been AEC. Could use this one here, AEC, CEF, FEB, BED, and DEG, and GEA, and add all those up, and of course they equal 360 degrees. Okay, and in fact that is the only answer for that one. Okay, that would be the only answer for that one. Angles at a point, when you have anything, if a diagram it looks like this, you will have only one answer when it comes to angles at a point, because in this case we are looking at 360 degrees, which is of course the measurement of a circle. Okay, and also is the measurement of all the angles in any quadrilateral. Okay, alrighty. Okay, here example 1. Let's go ahead. I know some of these are going to look really easy for you, but again, one of the most important things here is we're going to look to be writing some equations for these angle relationships, not necessarily just getting the answer. So this first one asks you to estimate the measurement of x. And of course, if you estimated the measurement of x, you could just, and again, this is like not if you know exactly that this is a line, but this is a line here, okay, this line BAD here, all right? So if we know that's a line, we could use that relationship, the angles on a line relationship, right? Angles on a line, and what we know about angles on a line, they're all going to equal up to 180 degrees. And of course, if we know that, we could take 180, which would be the total of both of these together, okay? And we could subtract away what we know, Okay, and this is all arithmetical now, okay? And we could see that that is going to be 48 degrees, okay? So this right here would be 48 degrees. Yeah, we could have, I'm just doing it actually, an actual measurement. I mean, you could have also just estimated 50 if you wanted to, because we're talking about an estimate here. But the truth is, you know it, okay? The second part, though, asks you to go ahead and write an equation for the angle relationship shown in that figure, okay? So what I want you to do, therefore, is I want you to go ahead and do this. See if you can write an equation, okay, right down here, and find the measures of angle BAC, and okay, and you can. These are to scale, and it says right here, for example, you can confirm your answers by measuring the angle with a protractor. Might be good to get that protractor out if you don't have it yet, and start using it. If you don't have it now, maybe in the future, we'll see how good of a job they've done creating these figures. So go ahead and try that, and then come on back. Alrighty, so here is this equation, a real simple one. X plus 132 equals 180, because we know that x plus 132 equals 180. That's what it looks like in equation form. If we're going to do this correctly, again, we are going to make a 0, trying to isolate the variable, and we do that by adding the additive inverse of 132 to both sides, and we get x equals 48. Now, to write it correctly and the way that they are going to be asking this to be written, measure. So you're going to use this little m here in the front of the angle you're finding the measurement for, equals 48. Okay, so this is the way it will be written. The measure of angle BAC equals 48 degrees. Okay, don't forget our little degree symbol. Okay, when you're working here, working through your equation, don't worry about that necessarily because it becomes a hassle, but you do worry about it when it comes to writing your final answer. Okay, for this exercise 1, again using some words to describe angles. In a complete sentence, describe the angle relationship in the diagram. Okay, so go ahead and see what you can do with that, and I will do it while I'm gone, and we can come back and compare answers. Okay, so here's my sentence, and again using abbreviations when you can, just saying angle BAC, angle CAD, and angle DAE are angles on a line. Okay, and of course they have a sum of 180. All right, sum of 180. Now, the next one asks you to find the measurements of angle BAC and angle DAE, of course, through using an equation, an algebraic equation, and hopefully you have an idea of how you might do that. Right now, one thing I need to, of course, remind you of, if you don't know it already, this symbol here, this little box, in any angle means that that is equals 90 degrees. Okay, that is our symbol for a right angle. Okay, a right angle. If you didn't quite know that yet. Okay, that's a right angle. All right. So yeah, go ahead and use an equation to come up with the measurements of BAC and DAE. Okay, so here's my equation, and again, very, very simple to set up. And as soon as you have that setup done, then you're cruising, okay? Because we know that angle BAC and angle CAD and angle DAE, they're all going to equal 180, we just write it out. But the only representation we have for BAC right now is 3x, okay? We have 90, okay, because we know that a right angle is 90 degrees. Again, we know it's a right angle based on that symbol, okay? And then DAE, we know is 2x, okay, and that's right there. So 3x plus 90 plus 2x equals 180, of course. That's angles on a line rule. Combine our like terms, 5x plus 90 equals 180. And then we go ahead and make a 0 on this side taking away the 90 with its additive inverse, do the same to the right side, and we end up with this at this point, 5x equals 90. Of course, we're going to make 1. We're trying to isolate 1x on the left, and of course what we do is we multiply by the multiplicative inverse, which is 1/5. Do the same on the right side, and finally we come up to the answer that x equals 18. Okay, now x equals 18. All right, but BAC is actually 3x, as you can see. So 3, then substitute x for now for 18. Okay, so that is going to equal 54 degrees. Okay, so we have BAC, angle measurement of angle BAC equals 54 degrees. Okay, and now we know that DAE equals 2x. So if we substitute the x for our 18, which we solved for here, we know that that equals 36 degrees. Okay, so the measurement of angle DAE equals 36 degrees. Okay, and so then if we could check that if we add them all, 54 plus 36 equals 90, plus another 90 equals 180. So it checks out. Okay, so here we go again. In a complete sentence, describe the angle relationship in the diagram. Now I want you to know that this is going to be not as simple as the first one, or simply written. I actually take two statements to write this one. Okay, so just think about that. Think of two different relationships that you can see in this problem. Okay, and then come on back and see what I've written. Okay, so yeah, like I said, there's a couple different relationships I wanted you to see in this one. And again, the reason we want to see these relationships is that we want to be able to solve for the various unknowns. As you can see, we have some unknown angles. We only actually know one angle measurement, okay, which is that one there, AEL, which is 144. Okay, so firstly, we know that AEL and LEB are angles on a line, okay, and they equal 180, okay, and we also know that AEL and KEB, okay, and here's KEB here, and then AEL there, okay, of course, all right, they are vertical. We know that they're vertical. We can see that they're vertical, and they are of equal measurement, all right, okay, so we can tell right now that AEL and KEB are vertical and therefore of equal measurement. So we actually know that we have 144 degrees right here as well. Okay. So what it asks you now is go ahead and write an equation for the angle relationship shown in the figure and solve for x and y. Oh gosh, we already solved for y already, didn't we? Well, okay, well, we know that already. So let's just go ahead and solve for x right here, okay? Go ahead and solve for x. Pretty easy. Okay, so here we go. Real simple. It's the simplest one of all, right? So we already figured out that that was 144 because we know that they're vertical, and therefore they are equal. So all we needed to do is just use the angles on a line formula, which is right here. X plus 144 equals 180. Again, take away the 144 from both sides. We ended up with x equals 36. So this was simply a simple x right there. Okay, so that was actually, we could substitute that in right now. 36 degrees. And we can write that right here. Something else we know, if you might recognize, we also know that the measure of angle KEA, okay, right here, is also going to equal 36 degrees. And therefore, that lets us know, or understand, that these KEA and LEB here are also vertical. Okay, so that is vertical. So also can show you that when you have a set pair of vertical angles here, which are equivalent, you know that these vertical angles are going to be equivalent as well. Okay, exercise 2. Here we go again. We're going to keep this going here. In a complete sentence, describe the angle relationships in the diagram. All right, so go ahead and do that. And then, of course, you're going to write an equation for the angle relationship shown in the figure and solve for x. Okay, so we're going to use the one. We only have one x value on this diagram. So go ahead and do all of that. Okay, do as much of it as you can. Come on back, and we can solve it together. Okay, so here's what we have, a little statement of these relationships. Angle JEN and angle NEM are adjacent angles. Okay, they're adjacent next to each other, sharing that common side, which is in the interior. And when you add those together, they are the measure of JEM. Okay, so you can see that right here. If we have JEN, and then we have NEM, okay, they are the same. When you equal, they are the sum. You add those together, and you get JEM. Okay, so you know this angle here plus this angle here equal this entire angle there. Okay, and that's just obvious. You can see that. Okay. Also, at the same time, you have a JEM, that one we just made in red there, and KEL. They are what we call vertical. Okay, and we know if they are vertical, they are of equal measurement. Okay, they're equal. All right. So we know a few things, and if we know a few things, and I want you to use the things that you think you know, and go ahead and write an equation and solve for x. Okay, so here's my work on this. My equation I created was 3x plus 16 equals 85. And where I got that from is here's my 3x, here's my 16, and here's my 85. Now the only way I knew that I could use that 85 is because I knew that KEL and JEM, those two angles were vertical. Okay, so I know that since this is 85, this entire thing is also 85 degrees. Okay, that angle. All right. So yeah, so then I went ahead and just did my my solution, and hopefully everybody's getting really familiar with this. Boopity boop, take a 16 away, isolating the x with the multiplicative inverse, and I end up with x equals 23. Okay, now x equals 23, of course, is not going to be the answer. Okay, because we want to know what 3x equals here. Okay, that 3x. So we're going to plug that in. So 3 times 23. That, of course, is going to equal 69 degrees. So right here, this total is 69 degrees. So angle JEN equals 69 degrees. Okay, and again, that would have been, I mean, you could have just, added it up, but we want you to work with your equations. All right, once again, in a complete sentence, describe the angle relationships in the diagram. Go ahead and do that, and then go ahead and write an equation based on those angle relationships. Okay, so we're going to find the measurement of angle EKF right there, EKF. And again, confirm your answers by measuring the angle with a protractor if you have one handy. Okay, do that. Come on back. Okay, so here we go. Here's my statement. Angle GKE, angle EKF, and GKF, which is over here. Okay, all of those are considered angles at a point, okay, and we know that angles at a point have a sum of 360 degrees, okay? All right, so knowing that going forward, again, knowing that is really important because that's going to allow us to, of course, put together our equation. Therefore, we know that x, which is here, plus 90, which is here, because that symbol tells us that that is 90 degrees, or a right angle, okay? And 135, all added together, equals 360, okay, because here's our 135, all right? Go ahead and just do our equation. Again, combining like terms, again, this is adding these two. That's going to get us x plus 225 equals 360. Taking away that 225 from both sides, and then we get x equals 135. So the measurement of angle EKF right here is actually 135 degrees, okay? And again, equation, using an equation, that's how we get that answer. Of course, you could have also added that plus that, subtracted from 360. But important that we're applying our equation knowledge to angles. Oh boy, look, another one of these. Alrighty. In a complete sentence, describe the angle relationships in the diagram and go ahead and find the measurement of angle GAH. A little bit of a twist. This looks a little different, huh? So go ahead and do that and come on back. Okay, so this was also a angles at a point, okay, because you see there is no actual straight line. Can be confusing sometimes, but your protractor can help you just understand that is not truly a straight line there, okay? Anywho, yeah, so the sentence I wrote here, or a little description here, was angles EAG, angle GAH, and angle FAE are angles at a point and whose sum is 360. Knowing that all of these together are going to be 360 degrees, I could just then very simply write all those angles out. I see there's 1, 2, 3, 4 different angles. And so x plus 1 is one of those. 59 is another. 103, another. 167, another. All of those are going to equal 360. I just took this out of parentheses here in this step right here. Okay, that's all I did. But then I combined all the numbers, okay, combining like terms, adding all those up, equals 360. Went ahead and took away my 330 from both sides to isolate that x to the point where I got to x equals 30. Okay, x equals 30. Now, the question was, though, the final task was to actually find the measurement of angle GAH. But the measure of GAH, of course, is going to equal is 30 is x plus 1. So then, therefore, it's going to have to be 30 plus 1 because we're going to substitute our 30 into there. 30 plus 1 equals 31 degrees. So the measurement of angle GAH equals 31 degrees. Okay, so before we get into to completing this example here, just wanted to show you that this is actually going to deal with ratios. Okay, so they're going to use a ratio statement here. So before we go ahead and tackle this problem, let's talk about this idea of ratio. So if you had a pair of angles, okay, whose measurements are in the ratio of 2 to 1, which is what's going to happen here actually, okay, what could those two angles be? Okay, what could those two angles be? Well, let me just start you off, and then maybe you could jump in with a few. Okay, you could have 90 degrees and 45 degrees, okay, because they are in the ratio of 2 to 1, whereas this one is twice the size of this one, okay, as 2 is twice the size, or 2 times 1, okay. What are another few examples? Okay, of course I'm not going to wait for you to say anything because I can't hear you, but how about 60 degrees to 30 degrees, okay? Again, 2 to 1. 150, 150 degrees to 75 degrees, and on and on. Okay, so we know if a pair of angles has a ratio of 2 to 1, then you know that one is going to be twice the size of the other, whereas the other is going to be half the size of the other. Okay, so for example, in this case, we know that 90 is twice the size of 45, but 45 is also 1/2 of 90. Okay, so it's 1/2 of 90. So if we were solving for 90, for example, we're solving for x, okay, and we wanted to, we first had the smaller angle size, then we would apply this, as that being half of the unknown. Okay, and again, we'll get to these. We'll be using these right now as we start this problem. Okay, alrighty. So let's go ahead and get started here. So let me go ahead. I'm just going to erase all this now that you know this. Hopefully, you've written that somewhere. Okay, just so you remember, or maybe that was pretty simple for you to understand. So the following two lines intersect. Okay, the ratio of the measurements of the obtuse angles and to the acute angle in any adjacent angle pair in this figure is 2 to 1. Okay, lots of vocabulary here to muddle through. Okay, obtuse. All right, here's some more language. Hopefully you know obtuse. Obtuse angles are the angles that are greater than obtuse, greater than 90 degrees. Okay, so greater than 90 degrees. Okay, that's an obtuse angle, and you can see that here because. Oops, I don't want to do that. Let me just erase this here. So, if we were to make some 90-degree angles here, and this was a straight line here, I could probably do something like that. Okay, here's 90-degree angle, and you can see that this angle here is obtuse because it is greater than 90 degrees. The acute angles are these smaller ones, okay, the acute ones, and you can see that this here is 90 degrees, this angle right here, so you can see that this angle here is smaller, so it's acute, okay, and equals, it's less than 90 degrees, all right, just so we know, all right. And so we have these adjacent angles right here, okay. This angle here is adjacent to this angle, and then on this other side, we have this angle adjacent to this angle, okay. So you can see right now, in this case, when these are drawn on a line like this, these adjacent angles, okay, drawn on this line, these two are going to equal, of course, are going to equal 180 degrees, okay, and these two are also going to equal 180 degrees, all right? Okay, so these are some things that we know. So let's go ahead and get to what they want us to do here. So it says here, in a complete sentence, describe the angle relationships in the diagram. Okay, so go ahead and the angle relationships in the diagram. Okay, now this is based on this information here, but let's just go ahead and do it together because I'm not sure if that's very clear. Okay. The measurement of an obtuse angle, again, like we said, is twice the measurement of an acute angle in the diagram, all right? So we would know, therefore, we could actually label this diagram. Oh, actually, that's the second part here. Okay, so let's go ahead and do that. I'm not sure exactly what this complete sentence they wanted. I don't really know. But let's just do it here. So knowing all that we know up here, we talked about obtuse, acute, that the fact that this is these adjacent angle pairs are 2 to 1, okay? So here's one pair. We could just deal with this pair here. These are a pair of adjacent angles, okay? So right here it tells you to label the diagram with the expressions that describe this relationship. And this relationship, again, is this 2-to-1 relationship. So I could just start you off here. The unknown is x. Okay? What could I put in front of these that would, should I put degree here? That would describe this relationship? Well, of course, I would put a 2x here, okay? Because first of all, I know that is the obtuse angle, and that's the larger of the two, okay? So based on the fact that it tells us right here, any adjacent angle pair in this figure is 2-to-1, okay? Then this would be 2x, and this would simply be x, okay? So we could write we could use these two expressions to describe these two angles right there. Okay, so now knowing that, we can go ahead and write an equation, because of course we need expressions before we can write an equation. Write an equation that models the angle relationship and solve for x, and then go ahead and find the measurements of the acute and obtuse angles. Okay, so you're going to find those measurements. So go ahead and do that. Write that equation out. You just use what you know, and come on back. Okay, so we could have written our equation just like this. Okay, we talked about these two, these two adjacent angles on a line. Okay, they were going to equal up to 180 degrees right here. Okay, angles on a line. So 2x plus x is going to equal 180. All right, combine like terms. 3x equals 180. Isolate that x with the multiplicative inverse of 3 to both sides, and we get x equals 60. Okay, so in this case, the little acute angle is 60 degrees. Okay, right there. All right, because it is x, and then 2x, of course, is going to be 120, because that's 2 times 60 is 120. And you can see if you add those two together, they're going to equal 180, and that's correct. Now you also know too that this one here, this angle here, is vertical to this one, so this is also going to be 60 degrees. And then this one here is also going to be 120, because it's also vertical to the 2x. Okay, so here's another one that uses a ratio. Okay, so it tells you right here the ratio of GFH to EFH is 2-to-3. In a complete sentence, describe the angle relationships in the diagram. Okay, so go ahead and see if you can figure this out yourself and write a good statement. And again, a good statement that's going to help us solve this, because eventually we're going to find the measures of GFH and EFH. Okay, so actually, you can go ahead and do the whole thing and then come on back and we'll check it. Okay, so they helped us out a little bit here by by giving us these expressions already for the angles GFH and EFH. Okay, but anyway, yeah. So my statement here was that the measurement of angle GFH to measurement of angle EFH is 2-to-3. Again, I didn't really need to apply that because, like I said, they already gave me the 2x and the 3x. But I'm sure you'll see something different in the future. I also know that angle GFH and angle EFH have a sum of 90 degrees. Okay, and I know that because of that symbol there. And again, very, very important to know, because that's very often not going to be ever labeled 90 degrees, but you're just going to have that little square in the corner there. Okay, so I know those. I know that, therefore, I can just go 2x plus 3x equals 90. 5x equals 90. Multiplied by the multiplicative inverse of 5 to isolate the x, and I end up finally with x equals 18. I'm going to apply that 18 by actually substituting it into these two, so 2x and 3x. So GFH right here is 36 degrees because it is 2x, so 2 times 18. And then EFH is 54 degrees because it is 3 times x, which is 3 times 18, which is 54. All right, so here's just some, again, some relevant vocabulary, things that we've been going over throughout this lesson. We also kind of tackled with some notes at the beginning. Again, just remember these. We'll be using these. There are plenty of other angle descriptions as well that we have not yet touched on, like complementary, supplementary, and others. And we'll get to those. But for now, these four right here are really, really important to understand. Adjacent angles, okay, two angles with the common side they're adjacent if C belongs to the interior of BAD. Of course, it means something like this, and then C was right over here, point C. Okay, if this were the case, and they are adjacent. Okay, vertical angles, of course, two angles are vertical if their sides form two pairs of opposite rays. What's really important, of course, is that they are equal. They are equal. Okay, vertical rays are always equal degrees. Okay, equal measurements. Angles on a line. Again, the sum of the measurements of all the adjacent angles on a line are 180 degrees, and then angles at a point. Same idea here. The sum of the measures of all the adjacent angles at a point are 360 degrees. Okay? So go ahead, do your exit ticket, get your problem sets done. Any questions, you could always call me. Okay, good luck.